Hi everyone, I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of Oracle Database and hopefully have a little bit of fun whilst doing so. So with that in mind, it's always great to be here for these office hours sessions. So this is your chance to ask me your questions about SQL. As always, we have a topic kind of theming the conversation. This time we'll be talking about SQL performance a bit, in particular how we can have queries that process millions or billions of rows, options we have to improve the performance of those. Got any questions? Please put them in the Q&A, the question and answer section. I'll be keeping half an eye on that as we go along, but type them in and I'll address those at various points throughout. If we've got some time at the end, maybe we'll have some time for other questions, but we'll see how we go. So let's go back over to the slides. So as I say, welcome. So a query like this is really common in reporting environments or kind of just basic analytics. What we're doing is counting how many orders and the value of those orders placed each day over the past 4 weeks. So we're grouping up by date and just getting some basic totals. And it's really common to have this kind of query. Thing is, the results of this query is going to be limited to at most 29 rows. So the 28 previous days and today. So that's all the previous 28 plus today. That's the maximum number of rows we are going to get in the output for this. But the query itself, we could be processing thousands, millions, maybe even billions of rows if your application is busy enough, you're popular enough company or business, you could have huge stacks of data that we are processing through here, and that can take a little time to do. So what I'm going to do is look at some options in this session to help improve the performance of these. So I'm going to go straight to a demo, and I'm going to spend pretty much all of this session in a demo walking through what we're doing here. So I've got a large table here, my classic table of bricks, loaded it up with 100 million rows, so quite a chunky size of data, and the table itself is 3.5 gigabytes in size. So currently I've got this slow query. I'll just bring the explain plan prediction about what's going to happen. So we're going to do a full table scan, and I'll start that running. So we're full scanning, 100 billion rows, cardinalities. Not quite right though. I'm not sure that's quite right with that, but we're going to read a lot of data. The database is going to scan all 3.5 gigabytes of that data. It's going to take a while. Basic principle. There's only so fast the database can process things. Even if you're on super zippy hardware. So I'm running on my one of my cloud instances, one of the extreme performance versions of Oracle Cloud. You see, this is still going to take a while just because we are processing huge gobs of data here. And I think this is kind of probably running long enough to kind of prove my point. It's not the fastest thing in the world. So let's just stop that so we can move on. Let's move on with our lives and see what's going on. Now, one of the first things that we might try when trying to improve this is, well, we're saying we've got this table of bricks here, 100 million rows. I've actually loaded up something like 20 years worth of insert dates, but we're only interested in the past week or so. So a small fraction of that data. So first tuning instinct is to try and create an index on that. So we'll create an index on that insert date. Because this is such a huge table and I don't want to have to sit around forever waiting for these indexes to build, I've actually created one. Here's one I made earlier, my little Blue Peter reference, for those of you who are British. So it was invisible, made it visible, and the optimizer can now use it. So we'll run this query again, and it was taking some ridiculous amount of time. Lost track how long I was talking before. You see, gets the results pretty quickly. So well under a second. Now, in many cases, this just creating that index would probably be good enough, at least in terms of response time. So we've drastically reduced from over a minute down to less than a second. Such is the power of well-created indexes. But the thing is, this query still processes a large amount of data, even when using that index. So we can see output rows over 100,000 rows. It's index entries that it's red here, and it's done a fair bit of work, read a lot of blocks to process this. So while in terms of response time it's pretty quick, we're still actually reading quite a lot of data. And if we kind of change this predicate a little bit, so instead of looking for the past week worth of data, we'll change it so we look for a year's worth of data or something like that. So we change that to 365 or a much larger value, 600 at some point is going to decide that either a full table scan is a better approach, or might stick with using the index for a long time. And as we fetch more and more data using it, it's just going to take longer and longer to do that. So index does reduce runtime, but still processes a lot of data. And there's always the risk that if we change what date range we're going to look for, either the index is still going to be too slow, or it's just going to switch to a full table scan at some point. So rather than using an index, it'd be nice if we could pre-compute the results of this query and store them. After all, things like orders placed per day tends not to change very much looking backwards. If it was placed yesterday, it's still going to be placed that day in the future. So let's just make that index invisible again so it goes away. What we can do is create a materialized view to store the results of this query. So we've got basically the same query that I had here, just without the where clause. So this is storing the entire of all history for this table. Now, just quickly, what's the difference between a materialized view and a regular view? Other than the keyword here, obviously, materialized, a regular view just stores the text of the query. When you access the view, it's exactly the same as if you just taken the query out of it and run it. The materialized view saves the result of this query in an actual data structure. So it's effectively a table. So what that means is we pre-computed and stored that result. Now again, this is going to take quite a while to run on my massive table here. So I have here's one I made earlier. That's why I've commented it out. I already have this. And if we now access that materialized view itself, we can see nice fast query because we are only reading the summary data. We're only reading 8 rows. A quick look at the plan, you can see we output 8 rows, do substantially less work than the original query that we had before. So let me just get rid of some of these other bits and bobs. So we're doing much less work than we did before. And because this is effectively a table, well, we could do even better. As I said, I've got something like 20 years worth of rows in here. I can actually index this to improve it even further. So let's just save that, and it will run the query. In terms of performance, we're not really going to notice any speed difference here because both the queries are already pretty quick. Or this, without the index, it's already pretty quick. So that's 600 microseconds, something like that. So under a millisecond. Okay, we made it a bit quicker by adding the index, but it's not really noticeable. But point here is we can still actually create these indexes on materialized view. Should that aggregate query performance still be too slow. So this is really cool. Instead of having to run the query and wait for tapping our fingers for several minutes or worrying about whether or not the database is actually going to use an index as we change our where clause, we can save the results of the query in a table and get good performance gains. But you'll notice I'm querying the materialized view itself. But how does it help us with our original query? We've got this query, and if we look at it, you can see that it still actually reads all the data. So you've got a whole bunch of queries in your application, and you're going, well, we want to make these quicker. I've got this written somewhere, and similar ones, want to speed them up, create this materialized view. Now we're going to go through and change all those queries, right? Well, there is a handy little trick. We can use query rewrite. So we'll recreate the material, or alter its properties to enable query rewrite. And now, hopefully, we get the plant. There we go. It's now automatically swapped in the materialized view instead of running against the bricks table directly. Just get the execution plan to prove it, and you can see it picked up that index I created as well. So this can be transparent to your application. You've got these really big aggregation queries where they're grouping data from millions or billions of rows down to a few thousand or even a few hundred, maybe just 5 or 6. You can get really good performance gains without actually having to change the code here. So this is really good. You just need to enable this query rewrite. And the benefits don't stop just there. So if we've got this, we can see we're grouping by both of these columns, the insert date and the color. Because we now have the totals for that at that granular level, the database can actually go, well, actually, if I've got a query where I'm just grouping by color or just grouping by date, instead of having to go to the table itself, well, I can just sum up those totals, right? I can just ignore the insert date effectively, look for things for each color in that saved materialized view and get the overall totals. So we can use the group bys on any subset of those group by columns. So if I run this, we'll see again, nice and quick, and it uses materialized view. Same if we group by color, or even if we just count all the rows in the table. Again, nice and quick, because if you look at the plan, there we go. It has used the materialized view. So it's not just limited to queries that exactly match those in whatever you've defined the query for the materialized view as long as the database can derive the results of your query using the data stored in the materialized view, it is eligible for query rewrite. So you could actually get nice performance gains for a wide range of queries throughout your application just by creating one materialized view at a fairly granular level of grouping. And it's not just limited to those aggregations. Now, it's not immediately apparent here, but I've really just joined in this colors table, and I've got the same grouping here. And hopefully we run this. There you go, nice and quick again. If we look, you can see we've got this materialized view rewrite. So at first glance, this doesn't match the query we had in materialized view at all, or at least not without a bit of thinking about it. But we're grouping by the same columns, and it knows based on whether or not they're mandatory that these two queries, it can derive the result of this query using the query in the materialized view by then just joining in the colors. So it can actually use it in some joins as well. I'll just do an explain plan actually. Let me close some of these other windows. Stop it getting a bit too messy here. So so we can rewrite with join, and if I get that little plan up, now you may not always find this. The optimizer, if you've got a much larger query and your materialized view query kind of buried in there as a subset of the data, you can't always figure this out. You have to make sure you've got all your appropriate constraints in there, make sure everything's not null that's supposed to be mandatory, foreign key relationships and so on. Often if those aren't present, it can't actually do that logical equivalence. And some more complicated queries it can't. In those cases, you might want to use the with clause and actually pull materialized view query into that and then join to the result of it later. And then it can go spot this and more easily and go, actually, this is exactly what is in that materialized view. We can use that. So if I just pin this, we'll see again, we can materialize view rewrite. Nice little thing, little optimization we've got here is originally with the previous join, we've got this little hash group by operation. So this one, it's getting the data sets and still having to do this group by afterwards. Here, because we've actually got the grouping from the materialized view in the query, it kind of knows it doesn't have to do that in this execution plan. So it saves itself an operation. So even if it is actually possible to rewrite the join, sometimes you might still, if you're trying to juice every last ounce of performance out of a query, you might still want to extract it into its own common table expression like this to do something like that. So there's a lot of applicability. Create one materialized view can be then generally applicable, but it's not applicable to everything. So this query looks very similar at first, but we see it goes back to the base table. And that is because we have got our insert date time in the where clause without the trunk, right? So trunk by default strips the time component off the date. So here we've got dates with all the times. So, that time information isn't in the materialized view, and it can't then rewrite the query to use this. So this can catch you out sometimes. Sometimes little subtle changes to your query can then break the rewrite equivalence. The optimizer can now no longer know for certain that the two queries actually give exactly the same result, and therefore it can swap in a materialized view nicely like that. And this can be a bit confusing in some scenarios. So in this, it's one of those where you might have to look at it a few minutes and kind of go, why isn't it rewriting? What's going on? Before you finally realize that you missed the trunk off here. But other, certainly more complicated queries, it's not always immediately apparent why it won't rewrite. And you're kind of like, come on, database, why aren't you rewriting? What's going on? How can I improve performance? Figure out what's going on here. So in those scenarios, what we can do, there's a procedure which will explain rewrite, actually tell us what rewrite options are available, what are the reasons for it not being able to rewrite. So this is my query, we'll pass that in, and I'm going to just run this. We will get it, and get the message up as well. Come on. And it will tell us something, what's going on. So materialized view, daily week summary requires join back to the table, insert date time. Some of these are not immediately apparent exactly what's going on, but basically these insert date time column, what it's saying is those values do not exist in the materialized view. Therefore, we have to kind of go join to the materialized view to get them. And of course, we don't have the primary key or any other information to go back at the row level to do that. So it's not immediately apparent, but that's what this is telling us. We need to put that trunk on here. Or you need to look at it a bit more closely, figure out we need to get that trunk on there. So Thinus, sorry, I'm not sure how to pronounce your name. Question about what happens when we change the data. Will the materialized view be kept in sync? So let's have a look and see what happens here. So I'm just going to insert one row in there and save it. And if we look at the plan now, we'll see it's fallen back on the index, primary key index, instead of actually using materialized view. So why is this? Well, at a basic level, there is a mismatch between the data in the materialized view and the data in the table. So the database will only swap them out when they match exactly. And that includes the entire data set. So you might query some rows which haven't changed, so they're exactly the same in the materialized view and the query. The optimizer will just go, nope, something's different, therefore I will disable all rewrites, so it becomes impossible. And if we run it through the rewrite, explain rewrite, and just do a nice simple count star here, see what's going on, and it will tell us the materialized view data is stale in enforced integrity mode. Another slightly cryptic message when you first see it, right? It's stale when it's in enforced mode. So what does that mean? Well, if we look at the materialized view, it says staleness stale. So there's various properties for this. It could be fresh, could be stale, a few other things. But that staleness means something has changed in the table, and that change has not been put back into the materialized view itself. So what can we do about this? Well, there is a sneaky cheaty option here, right? What we can do is set the query rewrite integrity to stale, tolerated. Okay, so what this says is kind of tells the database, well, I know the results could be different, but I don't care. I want you to use that materialized view anyway. So if we count the rows here, we see we get 100 million. Remember, we started with 100 million and I inserted one extra row. So this query should return 100 million and a 1. We've got the wrong answer here, according to what's actually in the table. But we have got the query rewrite. So at this point, you may go, well, why do we want to do this? Why would we want to use this stale, out-of-date data? Well, there's several possible reasons. The first is, I've kind of alluded to a bit before. You might know that the data you are querying has not changed. Classic example is querying on a historical data. So if you've got a table which is insert only, and you are querying for any data from before today, then the data in the table will exactly match what's in the materialized view, as long as you're aggregating at the daily level or lower. So because nothing from yesterday's ever going to change, as long as that's present in the materialized view at that date level, you can go, well, I know the information I'm interested in exactly matches what's in the table. So in this case, the data I want isn't stale, but this is where you've got to use your knowledge of the application, the data, and so on to figure out what's actually going on. The other thing is, notice, although this query is out of date and giving wrong information, it is really, really quick. So 0.015 seconds. So, about 100th of a second there. If I run this count against the table itself, potentially it could take much longer than that. Let's imagine that query takes, I don't know, a minute. If we are running the query against the table and start it now, takes a minute to run. By the time the query finishes, it's already out of date, right? It's a minute out of date. And how out of date that means depends on your kind of transaction volume. Could be not much difference, could be thousands and thousands of rows different. If you've got a table which is subject to hundreds or thousands of inserts a second, by the time a minute's finished, the query is going to give you a result which is hundreds of thousands wrong, okay? Or we could have used that slightly out of date information and got the answer instantly and straight away in a second. So again, now you're going to make that trade-off. Well, by the time the query is finished, the answer is going to be out of date anyway, so maybe I should already use information that's slightly out of date and get an answer that is just much quicker. So a lot of thinking and a lot of decisions you've got to make here to kind of figure out whether or not, what to do here. Do we want this stale data or not? Ideally, what we want is the materialized view to stay up to date and in sync with the table. So before we go on, I'll put it back to enforced, which means there needs to be exact match between the table and the materialized view. And this is a good point for some questions. This refresh is going to take quite a while to run, so I'll set that going and I will see what questions there are. Just briefly, when we've done the refresh here, what this is now doing is rerunning the query within this, and that's going to take, we saw that potentially take a few minutes to execute. So we're literally running the whole query again and replacing the entire contents of the materialized view. As we can see, this is going to take a little while. So I can see there's a couple of questions, so let's just take a look at those. So from Hachemi, what if more than one materialized view are query rewrite enabled? So good question. There's potential you might have two materialized views that are candidates for query rewrite. Now the thing is, the decision to use a query rewrite or not is still cost-based. So the optimizer figures out the cost of running the query without the materialized view, run the query with the materialized view, and then it can look at other candidate materialized views too. So basically it just chooses which of those it decides has the cheapest cost. So which in theory, hopefully, is the one that's fastest. So if I also created a materialized view which is just counting all the rows, as well as the one which was grouping by day, to answer count star of bricks, well, we're only reading one row, right? It's difficult to get much faster than that. So hopefully it should use the materialized view, which is just counting all the rows. But basically it's a cost-based decision and the optimizer will choose that way. So hopefully that answers your question, Hachemi. So, Abhilash, how do you identify candidates for materialized views? So that's another good question. And one of the key things here is you're looking at is typically they're long-running queries which process lots of data yet return relatively few. Anything that groups by day is probably a good candidate. Even if you run get the count of orders per day over an entire year, there's a maximum of 366 rows you are going to get in that query's results. Where again, depending on the nature of your business, it's likely to be processing thousands of rows, could easily be processing millions, billions. If you're a really, really big company, it could even be more than that. So trillions of rows that it actually reads, yet getting relatively few rows in results. So typically you want to look at queries where you've got lots of rows as in the input, but the results is just a handful. So we're consolidating lots down to a few. Counting by day is probably the classic example. Summarizing by customer potentially as well. If you've got a lot of repeat customers, people who come back over and over. Not quite so good if you've got lots of one-off customers. People only place one or two orders and never come back. Probably not exciting a great company, but anyway, the nature of some businesses mean that you get relatively few repeat customers, whereas others, you think like your weekly grocery food shop, you probably go to the same few shops over and over again. So they have customers come back many, many times. Anything where you're just going to consolidate many down to few, basically. So hopefully that helps answer that question. So Enrique, if the materialized view does not match the table it's based on, then it will fall back to the actual table to get the most accurate data. Correct? If I have a slow performing view, can I make a materialized view of it to improve performance? The data in the slow performing view does not change much. It is something you could look at doing. So if you've currently got a view where, let's just say it takes a few minutes to execute, instead of making it a regular view, you could look at changing it into a materialized view. However, you need to think carefully about how you're going to keep it in sync with the changes. We're going to talk a little bit more about that process in a minute. So just keep that in mind, Enrique, as we go along. Okay, one other thing. Okay, all right then. So I see another question. What if you fast or complete materialized views over database links? I'll come back to that at the end. All right then. So we saw this refresh process took a long time because that's what it had to do. What was called a complete refresh, rerun the entire query and replace the entire contents of the materialized view. But now I've done that, we've got nice super fast query again, and the database is choosing the materialized view because the tables are in sync. But that's a lot of work, right? I had to read 100 million rows when in fact I've only changed one row in the table. A lot of work to go to for, very little changes. So it'd be nice if we could just kind of incrementally do this. And good news is you can, doing a fast refresh, but there are some things you need to do, some setup, in order to put that in place. So I need to first up create materialized view log, which will capture the changes. I'm also going to need to do another complete refresh. So after creating the materialized view log, I have to do another complete refresh, sadly. So I'll set that going while I chatter for a bit more. And you can see there's a whole bunch of other options I've got here. And it's like, what are these all about? So this controls what is actually stored in the materialized view. So primary key, row ID, hopefully fairly self-explanatory. They will store the primary key columns for the rows that have changed and their row IDs. Sequence and commit SCN. So that is the order that the operations had, the sequence, and the commit SCN is the transaction relating to this particular change. Generally speaking, you do want to include those because it makes the actual refresh process a bit quicker. Occasionally you may not be able to due to various restrictions. And finally, we've got a list of the columns including the new values. So you want to list out all the columns in the table that you are going to have in your materialized view. So the simple way to do this is just to list every single column in the table. Simple but naive. There are some types of columns or some columns which you are probably never going to use in a materialized view, so you can kind of safely ignore them. You want to go with the ones which are commonly used in the materialized view, and then when you make a change, the database will capture their values in the table, in the materialized view log, with what the changes are. So it can then apply those when refreshing materialized view, as we'll see in a minute. So I see a couple of other questions come in. This refresh is still going, so let's get some more questions. So Sunny, what happens when trying to view an MV whilst it is being refreshed? Does it use the old stale data until the whole refresh is completed? So there are actually a couple of options for materialized view. So you can do kind of essentially a delete and then an insert. So a complete refresh essentially runs a delete statement on the materialized view and then reinserts the result of the query. And it does that in one transaction. So then that works like a delete and reinsert for a regular table. No one else will see the changes until it commits and the refresh is complete. So it kind of magically goes from the old data to the new data when the refresh process completes. Now, that delete process could take a long time. Got materialized view with lots of data. Delete is typically one of the slowest operations around. So if that's causing you problems, you can change it so it actually does a truncate instead. So this is what is called materialized view atomicity. I'm not sure if I'm saying that right, but there's a parameter atomic refresh. I always forget exactly which way around it goes, but by default it will do a delete and insert. We can change it so it does a truncate and then insert. The thing with is, if you do a truncate and then insert, there's a brief period when that materialized view is empty, so it sees anyone who happens to hit it will see no rows whatsoever. So you probably don't want to do that, but in some cases you might have to. So hopefully that answers the question, Sunny. Generally speaking, it will just magically go, it will be the old data up until the refresh is complete, and then suddenly it will look like the new data. Whereas with an non-atomic refresh, it will briefly be empty while the refresh process runs. Okay, question from Eric. Sometimes when I do DML on a base table, the DBA MVs data dictionary says the materialized view is stale, but sometimes it says needs compile. Okay, yes. Why the difference, and why does it say when one versus the other? So that's a good question, Eric. Sadly, I don't know the full list of rules, and I'm not sure they're all fully documented. So something to be aware of. Some changes you can make to the materialized view, to the table I should say, will invalidate the materialized view. The most obvious is if you drop a column in the table that's used in materialized view. Clearly then you've broken that dependency there, so it's not going to work. So various DDL you can run against the table can invalidate the materialized view, which can then lead it to needs compile state. There are a few other things. I confess I don't know the full ins and outs, the details of those, Eric. Maybe we can explore a bit later at the end. I think for the most part, you don't really need to worry about it. As long as it's fresh and doing rewrite when you want to do it, a rewrite is probably good enough most of the time. I'd only worry about this if it's stopping you do a refresh. Sometimes you might find you have to do a complete refresh to enable the fast refresh, which we'll see in a minute. Okay. Lots of other questions coming in. I'm going to move on a bit, and because we've got various other things I want to get through, so I'll come back in a bit later to some of these other questions. So now I've got this materialized view log. I can make it the materialized view fast refresh on commit. So what that means is every time we commit a change to the tables using the materialized view, the database will apply those automatically. And before we start, look at the staleness. So it's fresh, just complete refresh it, so we'd hope that. Refresh mode is fast and commit. And if we query the materialized view itself, we can see we've got my extra red row that I've stuck in there. So I'll just pin this results there so we can remember it, make sure I'm not doing any tricks or anything here. So now if I delete that row, so that's row 0, that is red. If we look in the materialized view log, so you get this little table, mlog $_ table name, when you create the materialized view, you can see it's got all the column values and lots of other lovely little gubbins here. When I hit commit, what the database does is it looks at these changes and then goes through the materialized view, updating as appropriate. So now, if we look at the staleness, it is now still fresh, even though we made a change to the table, because it took that row out of the materialized view log, which is now empty, so there's nothing there, it's used it up, and that red row has now disappeared from the materialized view. So we query it correctly, we can see we've just got the one row now, so we've removed that red row I inserted. So this keeps things in sync automatically. All you need to do is create that materialized view log, set it to be fast refresh on commit. Sounds great, sounds brilliant, right? Some problems, or potential problems here. Firstly, what this means is there's going to be a tiny bit of extra overhead added to every transaction involving these tables. So every time I insert, update, delete the bricks table and commit that, materialized view is going to be updated. So this adds a little bit of extra work to every single transaction for it. If you've got a really, really busy application or a really write-heavy application or one where you're just close to your server limits, that overhead might be just a little bit too much for your application capacity. It might have tipped things over the edge and really slow your application down. A lot of times this won't happen, but if you're really a heavy write application that's very heavily stressed currently, might add a bit too much overhead here. The other thing is it's a serialization point, so only one process can actually change the materialized view at once. If you've got hundreds or even thousands of concurrent transactions, so all happening at the same time, again, it might queue up and slow things down. So if you're really, really busy database, or you're just very, very underpowered hardware available for your, relative to your application, it might throw things down too much. So rather than fast refresh on commit, we can make it fast refresh on demand. What that means is when we call the refresh process, instead of having to rerun the whole query, it just applies the changes in the materialized view. But we have to do this manually. So either you've got to put it in your code somewhere, or probably submit a job which runs frequently to actually refresh the materialized view and update it. Which sounds nice, but this is a bit of a killer when it comes to query rewrite. Because what's going to happen here, let's say we've just done our fast refresh, we've called the refresh process, materialized view is nice and up to date, so we get query rewrite, instantly next transaction finishes and it's suddenly out of date and we're going back to the base tables again. So we get this flip-flop of performance potentially. Kind of thing that drives users crazy. The saying, people might not like slow queries, but they will typically live with it as long as it is predictable. If a query always takes 10 seconds to run, they might customers might grumble and be a bit unhappy, but ultimately they'll learn to live with it. They might check their email or something else while they wait for the query to run. A query which occasionally flicks between half a second and half a minute, randomly for no apparent reason, that's the kind of things that really drives people absolutely crackers and will come for them, they'll come for you, start kicking the door down, like, sort this out, right? So this can end up giving you unpredictable performance in terms of whether or not the query rewrite kicks in or not, in which case you're better off changing your queries to use the materialized view if you want the performance gains here. which is a bit of a faff, right? We create this materialized view to automatically swap it in. We don't want to then have to go through all the code to change it to actually access this directly. It'd be nice if we could automatically do that. Well, 12.2 added this other clause, enable on-query computation. So if I do that, what this means is, just refresh, make sure we're fresh. Yep, there we go, we're up to date. So now we've got my materialized view. Because we're on query computation, it can start with this as the basic results. Then when we do the refresh, it can apply the changes in the materialized view log. So when we query it, it can apply the changes in the materialized view log. So at this point, we've added an extra row, added that red row back in. When I query the materialized view, it's stale, it's out of date, doesn't include this row here. So we're going to get the wrong result here. But because it's on query computation, something magical can happen. If I run this query, we'll see it gets the right result. It includes the red row. And we look at the execution plan, we'll see something very, very scary. All right, it's a lot scarier than it really is. You can see all this weird and wonderful stuff going on here. So what this is doing is essentially going through the materialized view log, applying all the inserts, applying all the updates, applying all the deletes, which is why you see so many things going on here. So this kind of hybrid approach can really help you if you're not able to do a fast refresh on commit materialized view, because your starting point is the materialized view, so you don't have to read the table, and we're only applying the changes since it was made. So we can still get some good performance gains here. It's not going to be quite as fast as if we had fast refresh on commit, but hopefully it is still substantially faster than actually querying the table itself. Just bear in mind, the longer you leave it between refreshes, the more data is going to be in the materialized view log, so the more extra things we're going to process, so the slower this is going to be. So we might have this point, we refresh, we've got nice reading the materialized view directly, making some changes, and slowly get slower and slower and slower and slower, and then we refresh again and get nice, basically going against the materialized view, the log changes to apply, and keep getting this kind of thing where performance changes ever so gradually and gradually degrades between refreshes. Now, as long as you're doing refreshes frequently enough, most customers won't notice this. But again, if you leave it a long time, such as you've got thousands or more rows in that log, people might start to notice, and we get that unpredictable behavior again. So I'd recommend, if you're doing this, do your refreshes frequently. Now, frequently is one of those kind of subjective things, depends on your application, what the rate of change is for your database, and so on. I'll refresh that, and if we look now, run the query again, get the right result. But because there's nothing in the materialized view log, we just read the materialized view itself. So we've gone fast again. So on-query computation can help for those situations where you don't want to, or just don't have the capacity to do this on every as part of every transaction. So this is nice, but let's just disable that before we go on. But fast refresh does have other limitations. There are some types of query where you can't just take the changes that have happened since the last time, apply them to the materialized view, and get the correct result. The classic one of those is count distinct. So if my count distinct here returns 4, and I insert the weight, I don't know, 1,000,000 or 10, is 10 already included in that 4 that I've got? Don't know, right? There is no way to know. We've only got that summary of 4 in the results. So if we look at the capabilities here, it will tell us distinct clause on a duplicate sensitive function. You can't have this in a fast refreshable materialized view because there's just no logical way to be able to figure out whether that new value or values you've changed, how that affects the distinct. Now, we did have. Now, that doesn't mean you can't have count distinct in your materialized views. So we've got count distinct color here. Remember, color was one of the grouping columns. So we can use the materialized view for count distinct queries, but what have I done there? The columns you're distincting on must be in the group by. If we insert date, so without the trunk here, that's going to have to go to the table because the insert date and times are not in the materialized view. So it's got to be in the group by. So this is a bit of a faff. Luckily, 19C we added something called a bitmap-based count distinct. And what we can do is use these lovely bitmap functions instead of the count distinct in the query. It's not entirely apparent, what's going on here. I've not got full time to go into the details of these really right now, but for now, just know that you can use these bitmap and bucket number and so on things, and the database can automatically rewrite count distinct queries to use those. And if I run the materialized capabilities, we can see we can now fast refresh it. So fast refresh is now possible again, even though we've got count distinct. So that solves count distinct to some extent, but there are still other types of query where it is impossible to save the results and then just apply the deltas. Analytic functions are a classic example of that, because the result of this, so we've got count over order by. So this is the running total so far. That running total depends on what your where clause is. So if we change the where clause, we're going to get different results. So again, we can't use this in a fast refreshable materialized view. So window function in materialized view. So there's some things which you just logically cannot do in a fast refreshable materialized view. There's a few other technical restrictions as well, but it can be quite fiddly, particularly with complex queries, to get them to be fast refreshable. You have to think a bit more about your data and what's going on, and think about trade-offs, whether you can use stale data and things like that. So let's just look at, I'll come back to the questions. I see there's various other questions that come in, so I'll look at those in a bit more detail. Let's see. Okay, so Judith, will an MView refresh invalidate cursors currently in the library cache whose execution plan is not using MView because of staleness at hard pass time? Good question, Judith. I don't know off the top of my head. I'd have to look up that and see what happens there with cache invalidation has got incredibly complicated these days, and there's lots of bells and whistles in there to figure out when queries should and should not be invalidated. So I don't know the exact details of that. I'd have to look that up. Sorry. Maybe we've got time. We can have a bit of a fiddle around. Okay, Samuelash. Analytics tools like Tableau create views and extract data for this view and store it in their own Tableau databases. The tool's analytics dashboards then use local extracts for better performance. Would you like your views on this approach versus materialized views to accelerate analytics performance? Yeah, that's a good question. I mean, essentially, Tableau is creating its own materialized view. The advantage of doing it in the database itself is then it's applicable to other tools or applications that use the database. So you've got Tableau, and it's pulled the data in and created its own summary data, its own local materialized view. If you then connect up business objects or Oracle Analytics, OBIE, or whatever, any other tool, it might then go through and run the same process and get its own local copy of it as well. So we've got lots of different tools connecting to the database. Then it makes much more sense to do that as a single materialized view, because they can all take advantage of it, and potentially other reporting type queries within your application as well. It's quite common for applications to have like a monitoring dashboard, things like orders placed in the past day, or past hour, past day compared to the same hour previous week, so you can easily see if there's some kind of drop-off in orders to kind of warn people that maybe something's gone wrong, basically. You might not do that in Tableau. You might have done that your own custom way. So I prefer to do it in a database, because then it's more widely applicable. If you decide to change tools later, then they can just reuse what you've done. You do the work once, essentially. But essentially Tableau is creating its own materialized view. It can have its own advantages for doing that. I prefer to do it in a database. Other people, of course, welcome to have their own opinions. H. Cheng. Even if it is not a materialized view, but I don't know what to do, I have a SQL statement over a database link. It runs on the select statement. When I try and do the insert, it gives me selecting lobs over the database link. Yep. H. Cheng, if you could submit that question to Ask Tom, we can look at that in more details. So there's some limitations around using database links over lobs and so on and so forth. So if you can show us your code and example, create table, insert, demonstrating what you're doing, put that in Ask Tom. We'll look at in a bit more detail. Martin, can you cascade MVs with fast refresh, e.g. daily summary table based on hourly summary table based on minute summary table based on real database table? You can create chains of materialized views. There are ways of managing that. I don't know off the top of my head exactly. But the short answer is yes. The longer answer of how you exactly do it, I'd have to look up. But you can create materialized views on top of materialized views and on top of materialized views. And actually, provided you can make them all fast refresh on commit, then when you make the change to the base table, that can cascade all the way through. Obviously, then you're adding potentially a lot more work to each transaction, and in some cases that could be a bit too much work, but it isn't theoretically possible. So yes. And can you partition materialized views? Yes, you can partition materialized views. In fact, when it comes to refreshing options, there are some benefits you can get from having the partitioning in the materialized view match the partitioning in the base table. So you can there's things the database can do to improve those as well. Yeah, okay, and just Connor's had a comment about, I was mentioning before about the materialized view refresh, delete insert versus truncate insert. Delete insert might take too long. Truncate insert can leave you with a period where the materialized view is empty for too long. There's out of place refresh options. So again, I'm not going to have time to look at that in detail, but we can come back to that another day. Okay, so let's just disable query rewrite for a minute. So materialized views are really cool, but they do require a bit of finessing to get them to work right. Got to make sure your query is fast refreshable. You've got to keep your data in sync as possible. There's issues of whether or not you want to use stale data or not. Lots of questions you might have here, and you can easily end up small tweaks to your regular query can result in it not using materialized view unexpectedly. So as cool as they are, they can be a bit fiddly. So what else can we do to improve these kind of analytic type queries? Well, there's another option, in-memory. And this serves a very similar purpose to help us run analytic type queries where we're aggregating thousands, millions, or billions of rows down to just a handful. So I've had that disabled the whole time. I've had the table in memory. And one of the big differences is, in order to use it, basically all I need to do is this, alter table in memory. There's lots of other options, but at the basic level, all I need to do is this. And now all the queries are candidates for in memory. So we can see here, we're saying we're getting our in-memory full scan. If I want to do a count based on date, again, in-memory full, you'll see these are all nice fast queries. They're all using the in-memory column store. And we've got queries that my materialized view couldn't do at all. I didn't have shape in my materialized view in any form whatsoever. So, that it's just completely ineligible. Whereas, we just put my my table in memory, and there we go. It's all worked. Can also do it with these analytic function queries, so get the running total or running count. And just to show you what I mean about the where clause affecting the results here, so we got our 5 rows here. If we look at these P shaped prism and pyramid, if I put those in the where clause, we'll see we actually get a completely different count here because it's the running count so far. This demonstrates why fast refresh is not possible with analytic functions, because depending on what you put in the where clause, you will get different results. But in-memory can take advantage of this nice and easily. So nice thing about this, it is just much easier to set up, configure, and do. Now note, it is still a cost-based decision of whether or not you want to do this. If we just get one row, so we're switching on brick ID 0, that is single row lookups or finding few rows. It's still more efficient to process them in the regular way we would have done previously. Just use an index, primary key in this case, find the value from the table. So materialized views and in-memory solve a very similar use case generally, and that's when you're aggregating huge data sets down to relatively small data sets and selecting just a few columns from those. So at this point you go, well, we've got this lovely in-memory thing. It looks a bit easier to use. There's less gotchas in terms with keeping the refreshes going on. The database just keeps it transactionally in sync all the time. Why bother with materialized views? Well, if we enable query rewrite again, we'll see if we run our count star, database has decided rather than using in-memory, it's going to use the materialized view. Okay, and that's because when we do use in-memory, it's still processing the entire data set, essentially, still processing all those rows. Now, there's lots of optimizations in this to mean it's much faster than reading the regular table, but fundamentally, it's still reading everything. If I've got materialized view, which is just count all the rows in the table, one row going to be super quick to execute. So there are some use cases where materialized views will still come out faster than materialized in-memory, and even better, if you want to combine them, you can do both at the same time. So I've loaded that in-memory. Hopefully, it's a small thing, so it'll be in. Yeah, it's loaded in, and we can actually get materialized view in memory at the same time. So if you're looking for absolute extreme performance, you can do both of these at the same time, should you really need to. Okay, so I can see there's a couple of other questions. I'm just going to recap quickly, and then I'll come back to the questions if you want to hang around. So now at this point, some of you might be going, right, oh yeah, okay, Chris, you're just trying to sell us in memory, right? This is an extra option. You're just trying to get some extra money out of us. Well, maybe in the past, but things have changed recently. So from 19.8, there's something called the in-memory base level, which gets you 16 gigabytes of in-memory column store memory available to use with no additional cost. So it's included in your Enterprise Edition license. So you can actually now try this out. As long as you're fully patched up to the latest release, you can try this out, and you don't have to get the in-memory option to be able to use this. And 16 gigabytes is still, it's a fair chunk. For a lot of things, this can give you a good benefit. So to kind of recap and cover the differences between these, materialized view, you've got to think about your query, think about whether you want to make it fast refresh or how to fast refresh it. Do you enable query rewrite? How do you deal with stale data and things like that? Lots of decisions you've got to make here. In memory, just alter table set in memory. There's some other things you can do, but at a basic level, it is nice and simple, and you can just do that. So it's much easier. Materialized views, you've got to think about those refresh and rewrite limitations. In memory, kept transactionally consistent with the base tables automatically. Nothing extra you need to do here. So materialized views just generally a bit fiddlier. Sounds like database in memory is just a clear winner, and what we should always use, particularly if you've upgraded to the latest and greatest release. Well, materialized views does have a few advantages still. It's storing the results on disk, okay, which means you're just limited by your disk capacity. In memory, on the other hand, of course, clues in the name, it's coming out of your database memory, your server RAM, and it's only up to the in-memory size. Now, the key thing here is by enabling this, you are stealing memory from your other processes, from your buffer cache primarily. So you've got less memory available for those transactional processes. So, bit of a trade-off there. And the other thing is, Typically we measure disk sizes in terabytes. If you're going to buy a new hard drive, you think, how many terabytes am I going to get? Memory, we still tend to measure capacity in gigabytes. So we have orders of magnitude more capacity for disk, at least generally compared to memory, at least if you consider similar costing things. So you just got more space, more options for materialized views, whereas in memory, you might just be limited by how much physical RAM you've got or you can afford for your servers. The other thing, of course, the other kind of costing reason why you might prefer materialized views, they're in every edition of Oracle database. So they're in SE2. If you want query rewrite, you do need Enterprise Edition, but basic materialized views are in SE2. And if you're writing a reporting dashboard or any kind of reporting queries, can make, as long as you know you're going to be using that materialized view up front, you can just write your queries against that. In many ways, that saves you having to worry about lots of, is it going to rewrite, is it not going to rewrite, type agonizations. So it's fine if you want to go direct against the materialized views itself, that's fine, and you can do that in the SE2. In memory, you do need to be on Enterprise Edition with the 16 gigabyte base level only coming in the most recent patches. If you're not patched up to that, or you want more memory available, there's also some limitations around what you can do. You want more of the full feature set, you will still have to pay for the option. But it's a good thing to try out and see how it gets you going. Some links for you to check out. We are pretty much we're slightly over the hour actually. So if you want to head off, that's fine. I'll see you next time. Otherwise, I can see there's a couple of other questions that have come in. So I will hang around for a little bit and answer some of these. If you want to ask more, I can hang around for a few more minutes. So feel free to put some more questions in Q&A, and I'll address those in the coming minutes. Okay, so another question come in. When materialized view refresh is in progress, one that takes longer time for a refresh, does query rewrite use the previous version of the materialized view or the optimizer access the base tables? So when the refresh is in process, as long as you're not using the truncate, so if you're using fast refresh on commit, then the database can still use the materialized view even when it's applying those changes, because it's part of the commit time processing for that transaction. So it only becomes visible to everyone. The change to the table and the materialized view becomes visible when that commit completes. So that will affect, so the materialized view will see the old data and the new data, and the base table will see the old data and the new data at the same time. In all other scenarios, you're already working with stale data to some degree anyway, so I'm not sure that question's really relevant from all other scenarios. But if you fast refresh on commit, the change to the materialized view and the change to the table will be visible to everyone else at the same time. Okay, Alessandro, I sorry I missed that bit about aggregation materialized view. What was the function name? Bit and ag. So there's three functions. There's bitmap. I forget the names of them, Alessandro. Basically, if you look up bitmap-based count distinct, there's various things explaining what you need to do there. Like I said, I didn't have time to go into it today. Maybe we can discuss it in more detail in another session. I just wanted to highlight that it is in fact possible nowadays. But you're looking for the bitmap, three functions, they all start bitmap something. If you look at bitmap-based count distinct in the docs, that will walk through all the details of how you actually do that. Okay, a few other things I've seen coming in. Can we put the materialized view in the flash cache instead if physical RAM is not enough? It's not something I know immediately, FY. Ultimately we call it materialized view, but once it's saved, it works a lot like a regular table. So you can do a lot of similar things that you would to a regular table there, but I'd have to look up to find out exact details. Okay, another question from Eric. I have a one place where a fast refreshable MView has a constraint added to it to enforce a multi-row constraint. In your opinion, is this a bad idea? So that's an interesting, good question. So currently in Oracle database, and in fact most databases, there is no crate assertion constraint. All constraints work at the row level. If you want to do something across rows, for example, say there can be never more than 10 rows in this table, or 10 rows for a given customer in this table, you can't do it with check constraints. You might sort of be able to do it by creating foreign keys and primary keys and things like that, but it's a bit of a fiddle. Constraints across rows, generally speaking, you can't do with the constraints we have today. Materialized views allow you to do that by you put the query in the materialized view, you make it fast refresh on commit, and you have your check constraint or whatever it is in there to enforce whatever your rule is. So my thoughts on this are it is a bit fiddly to do, but if you have those options, if you want to do that enforcement in the database, it's generally a good idea. You kind of don't have any other options at the moment. There is on the database ideas forum a suggestion that we include create assertions in Oracle database, which would remove the need to do this. But hopefully we'll have it one day. You can read the full discussion of it there. But if you want to enforce those multi-row constraints, go for it. And materialized views are basically the only generally applicable way of doing this at the moment. Okay, so FY, what about autonomous ADW where there is no in-memory option and indexes are not recommended? Do we get same good result with materialized views? Yes, so materialized views can help you in any environment. And it's worth remembering, even if you've not got query rewrite enabled for whatever reason, either you're on SE2 or you've hit one of the various limitations, you can always rewrite your queries to go direct against the materialized view itself. So yes, you can use materialized views in the autonomous things if you want to do. It's a perfectly good idea, and it's worth trying should you want to do that. Okay, so Velasot, thank you for your answer. About out of place refresh. Creates one or more outside tables and executes the refresh statement on the outside tables. Are there any examples? The problem is when database links are not allowed between two databases. I could use external tables on Linux to create MVs on these, but what about the fast refresh? How can I use the MV logs remotely in the absence of database links? I don't think you can use MV logs remotely in the absence of database links. I'm sorry, I don't think there's any way around this. If you can, again, if you can explain your problem more thoroughly and submit it to us on Aftertime, we might be able to look into that. But I think, if you're trying to create materialized view across databases and so on, you have to have a database link, basically. If you've not got that, you probably want to be looking at some kind of change data capture thing, something like Golden Gate, where you're capturing the changes from one database and applying them to the other, possibly transforming them in the process. But yeah, I don't think you've got many other options there, really. For MV limitations like count sync, I understood they are relevant to query rewrite, and they are not limitations when I'm accessing the MV directly in the code. Yeah, so as long as you can access the materialized view, as long as you can change the code to access the materialized view, go ahead, that's fine, you're welcome to do that. Things like count distinct and analytic functions, they are about to do with the refresh process itself. Actually, with analytic functions, it's going to change your query results as well. So generally speaking, they're not going to work with materialized views. But if you can change your code to use the materialized view, you can go ahead and do that, and that will work for you. No, all right. So last question. We're gone 10 minutes over, so one last question, and then we'll wrap up and for proper this time. Okay. So question from Martin. Do you have a feel for the typical overhead of managing MV log table? I noticed that MV refresh, you create the log table took twice as long. So typically the materialized view refresh is pretty quick. again, it's one of those, how much you're changing in your transaction. If you're just changing 1 or 2 rows in your transaction and committing them pretty quickly, it's going to be minimal extra overhead. If, on the other hand, you've got some really big, gnarly transactions which change hundreds or thousands of rows, there's a lot more work that they need to do. So it could add extra processing overhead in those circumstances. But I know there are people who use these fast refresh on commit in busy applications, and they work perfectly fine. So as long as you keep your transaction sizes are pretty small, you're probably okay. But it always comes down to measure, test, figure out how it works in your application, what your performance requirements are, non-functional requirements, what your hardware capacity is, and so on. If you're at all worried, test it, try it out, play around. But yeah, absolutely, many people use this successfully with no real particular issues. So with that, I just want to say it's great to see you all. I hope to see you all again next time, and I really hope you'll enjoy this, but more importantly, I hope you learned something. See you soon. Stay safe. Goodbye.